Hello dear students! This is DP HL A.4. Welcome back to Rubber Duck Physics. Today we are going to explore a way of measuring angles that's absolutely essential for understanding circular and rotational motion, something called radians. You have probably heard of degrees. After all, 45 degrees and 90 degrees are pretty familiar terms, even outside of maths and science, aren't they? But radians, well, they might sound a little less intuitive. And I'll bet most people haven't heard pi/4 radians in everyday conversations. So why are we talking about them? Degrees are a great way to measure angles when we are just talking about everyday things, like turning a corner or slicing a pizza. We know that 90 degrees is a right angle, and 180 degrees is a straight line. Easy, right? But when it comes to science and physics, we need to use radians. Why? Because radians make working with circles much easier, and they connect directly to the way circles actually work. Let me show you how. A radian is simply a way to measure angles based on the radius of a circle. Here is how it works. Imagine our duck is floating along this circular pond. If the distance it floats matches the radius of the pond, we say that the angle it has turned is 1 radian. As our duck keeps floating, we can see that it takes about 6.28 radians, that's 2 pi radians, to go all the way around the pond, completing a full circle. So, a full circle is 2 pi radians, or 360 degrees. And that's how radians help us measure angles using the properties of the circle itself. So, how do we convert between degrees and radians? It's actually pretty simple. 1 radian is equal to about 57.3 degrees, and we use this conversion formula. 1 radian equals 180 degrees divided by pi. If 180 degrees is equal to pi radians, you can use that to convert between the two. Let's say you have an angle of 120 degrees. To convert it to radians, you would do this. 120 degrees equals 2 pi over 3 radians. Now, 2 pi over 3 radians might not roll off the tongue like 120 degrees, but it's going to help us a lot when we start working with circular motion in physics. When we work with circular motion, using radians allows us to relate angles directly to the radius and arc length of the circle. If we know the arc length, S, and the radius, R, we can find out how much the object has turned in radians by dividing S by R. That's why radians are so useful in physics. They let us describe rotation directly. As you can clearly see from the formula, we compare, which is mathematically we divide the arc length by the radius of the circle. Therefore, dimensionally, the radian is not a unit that evokes a specific quantity, like for example kilograms. It is length divided by length. It is a ratio. Its unit is 1. Let's try a quick example. Imagine our yellow duck is floating along an arc that's 3.5 meters long and the radius of the pond is 2 meters. What's the angle in radians? We use the formula theta equals S over R. So we divide 3.5 meters by 2 meters, which gives us 1.75 radians. And there you have it, 1.75 radians. Not a simple whole number, but exactly what we need. Now that you know how to measure angles in radians, let's think about how fast something moves around the circle. For instance, if our blue duck spins around once per second, what would we call that? And how could we describe its speed? We'll dive into that idea next time when we talked about angular velocity, a key quantity for describing how things move in circles. At the end, let me add that I'm also available for tutoring you online, whether in IB/DP Physics or in other similar curricula such as A-level Physics and Mathematics by any of the exam boards and AP Physics. Find my email address at the description of the Rubber Duck Physics YouTube channel, viewed in your web browser, not your smartphone application, and feel free to contact me for tutoring lessons. Thank you for watching the video, see you next time!